So now we are going to discuss 22nd problem, which is from 2003 AIPMT. An ideal gas heat engine operates at Carnot cycle between 227 and 127 degrees Celsius. It absorbs 6 kilocalorie at the high temperature. The amount of heat, also in kilocalorie converted into work, is equal to, we know that Q1 upon Q2 is equals to T1 upon T2. And work done is Q1 minus Q2. So temperatures were given. So it was easy to calculate the value of Q1 upon Q2. What was T1? T1 was 227 plus 273. It should be in Kelvin. What was T2? 127 plus 273. It is 500 and it is 400. The amount of heat absorbs is 6 kilocalories. Means Q1 is given 6 kilocalorie. In which unit you will put Q1? You will get Q2. So if Q1 is this, we know that Q2 is equals to, take Q2 on that side and 4 and 5 on this side, 4 upon 5 of Q1. It means 4 upon 5 of 6 kilocalorie. It is 1.2. 1.2 means it should be 4.8 now. So what work is done? Q1 minus Q2. 6 minus 4.8. It means 1.2 kilocalorie. So we got the answer D. 23rd. An ideal gas heat engine operates in Carnot cycle between 227 127. Same problem is again there. It is similar problem. They say 6 kilocalorie. Again they are saying 10 to the power means 3 means kilo. So little bit they changed. Problem is similar. It absorbs 6 into 10 to the power 4 means Q1 is given 60. I am taking 10 with 6 and for 30 I am writing kilocalories. T1 227 degree centigrade means again it is 500 Kelvin. T2 127 degree Celsius means 400 Kelvin. So what we are getting? Q1 upon Q2, T1 upon T2. So it means Q2 should be equal to Q1 into T2 by T1. What was Q1? 60 kilocalories. I am calculating in same unit. T2, it was 400 divided by 500. So again I am getting 5 12s are 60, 12 4s are 48 kilocalories. So work done is equals to Q1 minus Q2. 60 minus 48, 12 kilocalories. It means kilo means 10 to the power 3, 10 I am taking from 12. So I got 1.2 into 10 to the power 4 calories. So going with D option. See, it is 2006 AIPMT. A Carnot engine is working with efficiency 40%, temperature of sink is 300 Kelvin, we want to increase its efficiency by 50% of its original efficiency. The new temperature of source should be, means by how much temperature, by how much amount the temperature of source should be increased, so that there should be an increase of efficiency by 50% of its original efficiency. See, initial efficiency was 40%. It means it was 40 upon 100. It means initial efficiency, I am taking eta 1, was 2 by 5. New efficiency we want, it should be increased by 50% of old. Its 50% is 1 upon 5. So, new efficiency should be 3 upon 5. What it should be? 3 upon 5. Now, we will start. Initially efficiency was 2 by 5. 1 minus T2 by T1. Temperature of sink was 300. Suppose temperature of source was T1. So, we can do 300 by T1 is equals to 1 minus 2 by 5 means 3 by 5. So, T1 initially it was 300 into 5 by 3 means 500 Kelvin. What is the new scenario? We want efficiency 3 by 5. Sink is same. Suppose temperature of source is now T1 dash. So, 300 upon T1 dash, it should be 1 minus 3 by 5. Now, it is 2 by 5. So, T1 dash is equals to 300 into 5 divided by 2. It means 150 into 5. It should be now 750 Kelvin. So, what is change? So, change should be, it means you should increase the temperature of source by 750 minus 500 means 250 Kelvin. So, we are going with option D. Next, an engine has an efficiency of 1 by 6. When the temperature of sink is reduced by 62 degrees centigrade, its efficiency is doubled. Temperature of the source is, just we completed this problem. See, it was same as 62, this as 19th, and this is same, and we calculated only the temperature of source. It was 99 degrees centigrade, means same as 19, same as 19. So, we can go with option C. The first law of thermodynamics is concerned with conservation of energy. It is conservation of energy. If a gas is heated at constant pressure, then what percent of total heat supplied is used up of external work? Gas is heated at constant pressure. From calorimetry we know that heat supplied is equals to ms theta. M means number of moles, S means specific heat, we are doing at constant pressure. Theta means change in temperature, we are taking it delta T. But we know that Cp upon Cv is equals to gamma. So, we can write Cp gamma into Cv. So, we can write Q mu into gamma Cv into delta T. Now, we know that when we want to talk about change in internal energy. If you are supplying heat to a system at constant volume, all heat will be used to increase the internal energy. We want to increase by same temperature, so M S theta means if we want to increase the temperature by delta T, which happened at this case, the energy used to increase internal energy, it should be this. So we can calculate work done. What is work done? Work done, we know first law of thermodynamics, what energy you supplied minus what is spent in increasing the internal energy. So it should be, take mu Cv delta T common. So what is the remaining? Q minus delta T, it should be gamma minus 1. It should be gamma minus 1 mu Cv into delta T. So it is work done. What they are saying, what percent of total heat supplied is used up for external work, means we want to calculate this in percentage. You use W from Q. What percent means? W upon Q. What percent you have used? From Q you use W. From 1 you use Q upon W. From 100 you use, we can calculate this. So W upon Q into 100, we want in percent. So what you will get? You will get, when you divide this, mu Cv delta T will cancel out, gamma minus 1 upon gamma into 100. So what we are getting? Gamma is given 4 by 3. 4 by 3 minus 1, it is 1 by 3 divided by 4 by 3 into 100, cancel 3 with 3. So we got 25%. So we are going with option 25%, means A was correct. A sample of ideal gas is heated at constant pressure. If 100 joule of heat is supplied to the gas, the work done by the gas is. A sample of ideal gas is heated at constant pressure. We know that at constant pressure, heat supplied, just we solve in this. We can use this result, that delta Q, what heat you are supplying, Q, upon W, we are taking Q upon W, this result we are using here, Q upon W. What we got in Q upon W? Q upon W means gamma upon gamma minus 1. What we are getting? Gamma upon gamma minus 1. So in this case, 100 joule of heat was supplied. We want to calculate work done. So W is equals to Q into gamma minus 1 by gamma. Q was 100 joule. Gamma minus 1 is 0.4 upon gamma means 1.4. Remove this point with this point. 2 2s are 2 7s are, means you have to divide 200 by 7. 7 2s are 14, 60, 7 8s are 56, 40, 7 5s are 28.5. So we are going with A. When a system is taken from state I to state F along the path IAF, it is found 50 calorie, Q is equals to 50 calorie heat was absorbed because it is positive. Work done is also positive, 20 calorie. And when we are going with IBF, Q was given. See, I told you initially that change in internal energy is path independent. First, when we are going from this path I to A to F. By first law of thermodynamics, 50 calorie heat was given to system. What is law? dq is equals to du plus dw. And in that 50 was spent in doing work. So change in internal energy was 30 calories. By which path you will go to F? Change in internal energy should be same. So now I am going from I to B and B to F. They are saying along path IBF, energy supplied to system was 30 calories. In this change 36 calorie, it is 36 calorie dq. du is same from all path, remaining is work done. So in this path work done should be 36 minus 30 means 6 calories. So we are going with option B. Next, a gas under constant pressure then subjected to 800 kilojoule of heat. Change the volume from 0.5 to this. The change in internal energy of the gas is, pressure is given, change in volume is given, we can calculate work done. So problem is simple. We know the formula dq is equals to du plus dw. What is dq? When subjected to 800 kilojoule of heat is supplied to system, kilo means 1000. So we are talking about 8 into 10 to the power 5 joule. It was dq. We want to calculate du. What is work? Work is 4.5 into 10 to the power 5. Pressure into change in volume. 0.5 to 2 means 1.5. So what we are getting, du is, take 10 to the power 5 common, 8 minus 4.5 into 1.5. 6.75. We are doing in SI units means joule. It is 1.25 into 10 to the power 5 joule. So we are going with option D. A system is taken from state A to state B along two different paths. The heat absorbed and work done by the system along these two paths are this. Then we know that you go by which path? Change in internal energy should be same. Means dq minus dw. Energy absorbed minus work done. It should be same from first path or second path. So we are going with C. Heat is supplied to a diatomic gas at constant pressure. At constant pressure, we are supplying heat energy to a system. Again, same type of problem. It is what we calculated there. Just we calculated that what energy you are supplying, what work system is doing. The ratio should be gamma upon gamma minus 1. So we are taking this ratio. It is different in all the four cases. Gamma is given, it is diatomic gas, means 1 plus 2 by n. So gamma should be equal to 7 by 5. So it should be 7 by 5, 7 by 5 minus 1, 2 by 5. It should be 7 is to 2. Only in one option, so we are going with B. During an adiabatic process, the pressure of a gas is found to be proportional to the cube of its absolute temperature. What they are given in 33 problem? They are saying during an adiabatic process, the pressure of a gas means P is proportional to cube of its temperature T raised to the power 3. But in so many previous slides we saw that in adiabatic process P raised to the power 1 minus gamma, it should be proportional to T raised to the power minus gamma. It means P should be proportional to T raised to the power minus gamma upon 1 minus gamma. But they are saying no, it should be 3. It means gamma upon gamma minus 1 should be 3. Means gamma is equals to 3 gamma minus 3. So 2 gamma is equals to 3. So gamma is equals to 3 by 2. Means 1 plus 1 by 2. 1 plus, it is 3 by 2. So what is the 3 by 2 means? Okay, they are only talking about gamma Cp upon Cv. So we got gamma 3 by 2, not asking which type of gas this is. They are asking only about gamma. So we got the gamma, means we will go with option D. We will go with option D. In a cyclic process, work done by the system is, in cyclic process, no change in internal energy. What heat you are supplying, all will be used to do work equal to heat given to the system. So going with C. Thermodynamic process shown in the figure. In process A to B, 600 joule, system is gaining 600 joule. And from B to D, it is 200 joule. So we can calculate change in internal energy first along this path. If we are going from A to B and B to D, A to B and B to D. A to B, work done 0. A to B, why work done 0? No volume change is there. So dQ should be equal to du plus dw. What heat we are supplying? 600. So change in internal energy 600. It is 0. So du is 600. Now we are moving from B to D. B to D, dQ is 200 joule. du. What is work done? Pressure is 8 into 10 to the power 4. Change in volume 2 into 10 to the power minus 3 to 5 into 10 to the power minus 3 means 3 into 10 to the power minus 3. So 200 is equals to du plus 240. So what we are getting? du minus 40. So it means from ABD, when we are approaching from A to B, B to D, total change in internal energy is 600 minus 40. It should be 560 joule. The total heat added in the process ACD. Now we are moving from A to C and C to D. In process A to C, C to D, no work is done. Change in internal energy. In this case, it should be same. If you are moving from A to C and C to D, change in internal energy is same. What work we have to done? From A to C, we have to do work, pressure into change in volume. It is 3 into 10 to the power minus 3. This work you have to do. So work done in this process, it is 90 joule. It is 3 into 3, 9, 90 joule. C to D, no work. C to D, no work. So when we move from A to C and C to D, total work, it is 90 plus 0 is 90. Change in internal energy, it is same in both paths, so it should be 600. What was initial? Initial change in energy was 560, so it should be 560. So now total heat needed is dq plus dw. dq is equals to du plus dw. du is 560 and external work for we need 90 joule. So we got 650 joule. So we are going with option B. Next, in ideal gas is taken through the cycle A to B, B to C, C to A. The net heat supplied to the gas in the cycle is 5 joule. The work done by the gas in the process, we supplied 5 joule, means dq was 5 joule, process was cyclic, so change in internal energy, it should be 0. But we know that dq is equals to du plus dw. We went A to B, then B to C, then C to A. We came back to A, change in internal energy 0. Heat supplied to the system was 5 joule. So it was 5 joule. Change in internal energy was 0. What work we have to the work done by the gas in the process is, what we are taking here, the area of this figure, it will give you the work done. Work done by the gas in the process, we need total work done is equals to, what is the area of this? The length of this side is A to B, it is a closed figure. So from 1 to 2, it is 1 and it is 1 to 10. The area of this figure, we can calculate the work done by the gas in the process. The work done by the system we can calculate. The work done by the system is dq is 5 joule, du is 0, it is dw. So dw work done by the system. Ideal gas is taken through the cycle A to B, then B to C, then C to A. If the net heat supplied to the gas in the cycle is 5 joule, it was 5 joule. The work done by the gas in the process C to A, we want to calculate only from C to A, not total. See, what will happen now? From C to A when we are coming, we want to calculate work done by the system. So total work done is 5 joule. A to B work done is 0. What is total work done? Total work done means work done from A to B plus work done from B to C plus work done from C to A. Total work done, we know that it should be 5 joule. A to B volume is changing by what amount? 1 and pressure is 10. So A to B work done was pressure into change in volume 2 minus 1 plus work done in BC, volume was constant, so it should be 0. So now we can calculate WCA, it is 5. So what we are getting? 10 WCA is 5 minus 10, so it should be minus 5 joule. So, we are going with option A. We are going with option A. Next, the work done by the system in closed path ABCA. In closed path, it should be area of this triangle. It is a right angle triangle. So, work done means area. Area is half base into height. Base is V2 minus V1 and height is P2 minus P1. So, work done should be V2 minus V1, P2 minus P1 by 2. So, we got this option. A motor car tire has a pressure of 2 atmospheres. Suddenly burst. Suddenly burst means adiabatic process. Initial pressure was 2 atmosphere. Finally, it will become 1 atmospheric pressure. Initial temperature was 27 means 300 Kelvin. What is the relation between pressure and temperature in adiabatic process? Pressure should be proportional to, or we can write P raised to the power 1 minus gamma into T to the power gamma constant. P raised to the power 1 minus gamma into T raised to the power gamma. P raised to the power 1 minus gamma into T raised to the power gamma. It should be constant. Gamma they gave 1.4. What is the initial value? P1 raised to the power 1 minus gamma into T1 raised to the power gamma. It should be equal to P2 raised to the power 1 minus gamma, T2 raised to the power gamma. So, what we are getting? T2 raised to the power gamma is equals to T1 raised to the power gamma into P1 upon P2 raised to the power 1 minus gamma. T1 is given 300 Kelvin. So, take power 1 upon gamma. So, we will get T2 is equals to T1 into P1 by P2. P1 was 2, P2 was 1. 1 minus gamma by gamma. So, we have to calculate 300 into 2 raised to the power 1 minus gamma means 0.4 upon 1.4. 0.4 upon 1.4. Remove this decimal. It means 2 by 7. 300 raised to the power into 2 raised to the power 2 by 7. So, approx we can calculate. Only we can go approximal calculation, we will get 4 raised to the power 1 by 7. So, we can only do approximal calculation for this, or you can get, if they are allowing the because this number is now less than 1. If it is less than 1, it will reduce, nearly it will come to 46 Kelvin. So, in degree Celsius, 246 minus 273. So, what you will get? 13 minus 6, 7. 5 minus 4. So, what nearly we will get? It will come near about 246 or 250 means 2 raised to the power 2 by 7 we can calculate by simple calculator they are allowing us. So, we can calculate this by simple calculator, nearly you will get this number by calculator. It is coming nearly 256. So, when we subtract 273 from this, not coming 256, it is coming to, it is 2 raised to the power 2 by 7, 1.21. So, it is 300. We want to calculate a motor car tire has a pressure of 2 atmospheres. So, P1 was 2 and suddenly it burst. So what we are getting there, PV raised to the power gamma, it should be constant. PV is equals to mu RT. So it is mu RT by P. It should be constant. So P raised to the power 1 minus gamma, T raised to the power gamma, it should be constant. Initially it was P1, it was T1, P2, T2. Initial pressure was 2 atmosphere, final pressure was 1 atmosphere. So what we are getting, T2 raised to the power gamma means T1 raised to the power gamma into P1 upon P2 raised to the power 1 minus gamma. Transferring the power gamma on that side, 1 minus gamma by gamma. So we are getting 2 raised to the power 1 minus gamma. It is 1 minus gamma upon gamma, so power should be negative. It will come in denominator. It is negative power, so it will come in denominator. It is nearly 1.21. So when we will divide the 300 Kelvin, 300 Kelvin by 1.21, we will get 247. So we are getting 247 Kelvin. We will get 247 Kelvin. It means when we will convert in degree Celsius, 273 minus 247, nearly you will get minus 27 degrees Celsius. So we will go with option C. We will go with option C. They are allowing you simple calculators. We can calculate with the help of that. I did same. 39th, 2 moles of helium gas undergoes a cyclic process as shown in the figure. What we are observing, in some process temperature is constant and in some process temperature was not constant, pressure is constant. So we can calculate if pressure is constant and in one process temperature is constant. So if pressure is constant, it is easy. So we will check first A to B. Net work done means WAB, WBC, WCD, then WDA. First A to B, pressure is constant, volume pressure is constant. So we want to check what is the change in volume. If pressure is constant, work done is P into V2 minus V1. But we know that PV is equals to mu RT. PV is equals to mu RT. So pressure into change in volume, which is work done, it should be equal to mu R into T2 minus T1. So WAB is mu R. What is mu? 2 mole gas. Mu R. T2 minus T1. 400 minus 300 is 100. Plus WBC. It is isothermal process. So work done should be equal to mu RT. Mu is 2. R is R. Temperature is 400 log V2 upon V1, log V2 upon V1, and since temperature is constant, so PV1, P1, V1, it should be equal to P2, V2. So log V2 upon V1, we can write P1 upon P2. So log P1 upon P2 C2D. P1 was 1, so it is 1 by 2 plus WDA. It was WAB, WBC, it was WCD. WCD means what we calculated this, it was okay, mu R. WBC is okay. B to C means temperature was constant. Temperature was constant, it means 2R into 400. So we did this. P into V2 mu R, it is temperature difference is, first we got WAB. WAB means temperature was constant. Pressure was constant when we are moving from A to B. Pressure into change in volume is work. So V2 minus V1, P into V2 V1 minus V1 means mu R, temperature change was 100. Now B to C, when we are moving, temperature was constant. So formula is mu RT log V2 upon V1. V2 upon V1 means P1 upon P2. So it should be 2 by 1. It should be 2 by 1. Plus, now we are moving from C to D. C to D, again pressure is constant. So work done should be pressure into change in volume. So mu R 2 R into T2 minus T1, it is minus 100 now. Plus, now we are moving from D to A. So D to A, again temperature is constant. So mu RT 2 R, temperature is now 300. Log V2 upon V1 means 1 by 2, pressure is 1 or we are going to 2. So log, it is log 1 by 2. So see, this term is cancelled out. 400 to 800 R log 2, it is minus 600 R log 2. So we got 200 R log 2. So we are going with option A. Next, a cyclic process is shown in figure. Work done in cyclic process means area. Area means area of trapezium, half sum of parallel side. AB means, one is AB, 1 to 3, it is 2. CD means 1, 2 plus 1, 3. 3 meter cube SI unit into distance between them. Distance between them is 2 into 10 to the power 2 minus 10 to the power 2. 1 into 10 to the power 2. 10 to the power 2 means 100. So 300 by 2 means 150 joule. Next, 1 mole of again ideal diatomic gas, monoatomic gas at temperature T0 expands slowly according to the law P by V. Remember, the process for which PV raised to the power x is equals to constant. For that type of process, molar heat specific capacity is given by R by gamma minus 1 plus R by 1 minus x. In this process, P upon V is constant, means P into V raised to the power minus 1 is constant. So for this, x is equals to minus 1. So molar specific heat we will get by the formula R upon gamma minus 1 plus 1 minus minus 1 means 2, R by 2. So in this way we got the value of C. Gamma is given ideal monoatomic gas. So gamma should be 5 by 3. So what we are getting, R upon 5 by 3 minus 1 plus R by 2. So molar specific heat is given by, it is 2 by 3 means 3 by 2. 3 by 2 and 1 by 2 means 2R. So heat supplied should be heat supplied should be N, number of moles, which is given 1 mole. So mu Cv into change in temperature, it is T naught. So we are going with 2R T naught. 400 cc volume of a gas having gamma 5/2 suddenly compressed to 100 cc. Its pressure was P, final pressure. Simple, PV raised to the power gamma should be constant. Initial pressure was P. Initial volume we are taking 400 cc, gamma 5/2. Units are same. Again, pressure we want to calculate. It is 100 raised to the power 5/2. So new pressure should be old pressure into 4 raised to the power 5/2. 4 raised to the power 1/2 is 2, 2 raised to the power 5 is 32. So we are going with 32P. 43. Polyatomic gas is compressed to 1/8. Again same law. P1 V1 raised to the power gamma is equals to P2 V2 raised to the power gamma. What is P1? P1 was P naught. What was initial pressure? V. Final pressure V/8 to the power gamma. It should be new pressure. So what we are getting? P2 is equals to P naught into 8 raised to the power 4/3. 8 raised to the power 1/3, 2, 2 raised to the power 4, 16. So we are getting 16 P naught. An ideal gas is taken round a cyclic process represented by the triangle ABC. The coordinates are given. We know that work done means area under curve. So we have to calculate the area of triangle. You know that what is the area of triangle? Half. Determinant, x coordinates are 4, 2 and 2. Y coordinates are 1, 4 and 1 and 1, 1, 1. Only we have to solve this determinant. 1/2, 4 into 4 minus 1, 3, minus 1 into, hide the row and column of 1, 2 minus 2, 0, plus 1 into, hide the row and column, 2 minus 8, minus 6. So what we are getting? 1/2 into 12 minus 6, 6. So we are getting 3 units. So we are going with C. A given mass of gas is compressed isothermally until its pressure is doubled. Isothermally, pressure, initial pressure is P, final pressure is 2P. Isothermal means PV raised to the P1 V1 should be equal to P2 V2. If initial volume is V1, what should be new volume? P1 is P, P2 is 2P and volume is V2. So what we are getting? New volume is V1/2. What they are saying? It is now allowed expand adiabatically until its original volume is restored. Means now its pressure is P2 is 2P and new pressure P3 is equals to 0.75. New volume is V/2, V1/2. V3 we want V1. So again P2 means 2P. It is, they are saying it is this 0.75 of P. It is 2P, volume V1/2 raised to the power gamma. P3 means 0.75 P into V1 raised to the power gamma. Cancel V1 raised to the power gamma with that, P with P. So what we are getting? We are getting 2 raised to the power gamma is equals to, take this 2 raised to the power gamma on that side. This side we are getting 2 upon 0.75. It means 0.75 means 3/4, 8/3. So take, again we have to take the value of what should be the power of 2 so that it can give you gamma. Take log on both sides. So log 2, gamma into log 2 is log 8 by 3. So by this we can calculate log 2 value, we know that. So divide the value of log 8 by 3 by the value of log 2, you will get the correct answer of gamma. So in this way we can calculate gamma by log 8 by 3 divided by log 2. So simple calculator is again allowed. So we can calculate with the help of calculator what should be the value of log. So we are now calculating log 2.66 divided by, so log 2.66, this is equals to 0.978 divided by log 2, we are getting 1.34, means nearly 1.41. So we are going with option B. So nearly we can get this answer 1.41. So in this way it was the end of your 6th unit, but in competitive they will not give you this type of complicated calculations. They will give you numbers so that you can calculate easily. Thank you.